Okay, so I want to work the 8th problem from our review activity. And in this problem, we're looking at the explosion of a volcano, Krakatoa, in the 1880s. It says the volcano injected dust to a height of 32 kilometers in the atmosphere, and that dust then took 15 months to settle gravitationally out of the atmosphere. And so then if we assume that there was a constant terminal settling velocity of this dust over that time period, and if we neglect the slip correction, then what is the minimum size of the particles present? We can assume that the particles are spheres with a density of 2,700 kilograms per cubic meter. Okay, so we can first calculate the terminal settling velocity from this distance in time. So if things were falling over a distance of 32 kilometers or 32,000 meters, 15 months each have approximately 30 days with 24 hours and 3,600 seconds per day. So that's our time in the denominator. That works out to a settling velocity of 8.23 times 10 to the minus 4 meters per second. So pretty slow terminal settling velocity. If we assume that things are in the Stokes regime, then our terminal settling velocity is given by the particle density, size squared, gravitational acceleration, and our Cunningham correction factor. We can assume that things are spherical so that we ignore this dynamic shape factor, and the problem told us we could ignore the slip correction, so we'll set that equal to 1. Then we want to solve for the size of the particles, so we plug in this velocity that we've calculated, take our density of particles, which is 2,700 kilograms cubic meter dp squared. So gravitational acceleration, and they're falling through air. We can then also assume that that air is at approximately standard conditions. And if we then rearrange this and solve for dp, then we should get about 3.2 times 10 to the minus 6 meters, or 3.2 microns for our particle size.